Very good. Let's take a look at homework 6.1, question 1. Well, we are going back to elementary calculus. It says, suppose you have the series -1 to power n divided by x to the n and starts from 1, goes to infinity. And the question says, well, what is the interval and the radius of convergence? Interval and the radius of convergence. First of all, remember that to find the interval and radius of convergence, we need to find the limit. So we are going back to elementary calculus, limit of, well, here you have your general term, which is -1 to power n divided by n. So let us call this guy a sub n. And you need to find the limit of absolute value of an plus 1 divided by an as n goes to infinity. So for this case, the limit of -1 to power n plus 1, x to power n plus 1 divided by n plus 1 over an, which is -1 to power n, x to the n divided by n as n goes to infinity. You can write this as, well, -1 to power n and -1 to power n, they cancel out. So left with the limit of absolute value of -1 to power 1, x to n times x divided by, so if you just flip this, you get n divided by x to the n times n plus 1 as n goes to infinity. Just pure simple limit. Here you can cancel out x to the n, x to the n, and since you have absolute value, the absolute value of -1, it just gets to be 1. So we have the limit of absolute value of x times n divided by n plus 1. But as we all know, the limit of n over n plus 1 as n approaches infinity is equal to 1. So this guy becomes absolute value of x. So we know that a series is absolutely convergent if this absolute value is less than 1. You will recall the series is absolutely, because we're using the absolute value, absolutely convergent if this absolute value of x is less than 1. Well, it means that x is sandwiched between -1 and 1, or the interval of convergence is open interval -1 to 1. So since you have -1 to power n, we need to check to see what are the values for the boundary points, like -1 and 1, and what's the behavior of this power series at boundary points. So if x is equal to -1, what would be the behavior of your series? This series becomes the series of -1 to power n, -1 to power n, instead of x we use -1, divided by n, which is the series -1 to power, well, here you have 2n divided by n, and starts from 1, goes to infinity. Well, as you can see, if you use -1 into the power series, what do you get? You get the series 1 divided by n, and as we know, this is a divergent series. Well, what if I plug in 1 into the power series? So this guy becomes the sum -1 to power n and 1 to power n divided by n, and starts from 1 to infinity, which becomes, well, the sum -1 to power n divided by n, and starts from 1 to infinity. And this is a convergent series. This is an oscillating convergent series. Convergent. So since you have a convergent series, your final decision about the radius of convergence is going to be just 1 radius of convergence becomes 1 And the interval of convergence, we do not include -1. We include just 1 because the series is convergent if x is equal to 1. So we're not really worried about this. -1 and 1 is included.